Welcome to this video lecture series on transportation engineering. In this session, we shall discuss on the rigid pavements. So the rigid pavements are the pavements that possesses the noteworthy flexural strength or the flexural rigidity. That is the resistance offered by that material against deformation. And the pressures transmitted from the surface layers, they are not transferred from the grain to grain action as it was in the case of the flexible pavements. The rigid pavements, they are made up of the Portland cement concrete, which are either plain, reinforced or prestressed concrete. The plain cement concrete slabs, they are expected to sustain up to 45 kg per centimeter square of the flexural stress, and the rigid pavements, they have the slab action and they are capable of transmitting the wheel load stresses through a wider area below. The main point of the difference of the structural behavior of the rigid pavement as compared to the flexible pavement is the critical condition of the stress from the rigid pavement is that the maximum flexural stress is occurring from the slab because the wheel load and the temperature changes, whereas from the flexible pavement point of view, it's the distribution of the compressive stresses. The rigid pavements or the cement concrete pavements, they are designed and constructed for a design life of 30 years. Now, where actually the rigid pavements they are needed? Rigid pavements usually they are provided wherever there is very heavy rainfall and the existing soil conditions in the area where the road has to be constructed, they are very poor. Also, wherever there is the poor drainage condition and the climatic conditions, they are extreme, and the combination of some of these conditions which may again lead to the development of the cracks in the pavements. Because if you see all the conditions wherein the rigid pavements they are needed, or the type of pavement to be constructed, if it has these sorts of conditions prevailing on the site, the best suited will be the rigid pavements. Now next, if you just see the structure of the rigid pavements as compared to the flexible pavement, the rigid pavement, it comes up with the natural formation at the bottom, then the subbase layer and the topmost layer, that is the concrete slab with the desired thickness depending upon the total amount of load to be transmitted from the concrete slab or the top surface to the subbase course. And if you see in the flexible pavement as compared to the rigid pavement, there is no doubt more number of courses or layers formed or used in order to construct the flexible pavement. So here this rigid pavement, it is having the advantage regarding the reduction in the various sorts of courses which eventually lead to the decrease in the material use. Next, the components of the rigid pavements. So the components of the rigid pavements from the bottom to the top consist of the soil subgrade, then the granular subbase course, the base course, and the cement concrete or the PQC pavement slab. Now the subgrade soil. So the subgrade soil of the rigid pavement, it consists of the natural or the selected soil from the identified locations which actually fulfill the specified or the standardized requirements as per the design of the rigid pavement. And this soil it should contain required density and sufficient engineering properties. The subgrade ultimately supports all the layers of the rigid pavement and the traffic loads. The compressive stresses transmitting to the subgrade, they are very low, and there is no need to consider the allowable vertical stresses as in the case of the subgrade soil. Then the strength of the soil subgrade, it is generally evaluated by adopting the plate load test on the site, and here relatively we have to use the larger diameter plate so that the load supporting capacity of the subgrade, it is assessed in terms of the modulus of subgrade reaction, that is K. So this modulus of subgrade reaction K, it may be again defined as the pressure sustained per unit deformation of the subgrade at a specified deformation or penetration using the specified plate size, that is of 75 centimeters. But in case of the highway pavements, the plate of 30 centimeters it is generally used. The granular subbase course, that is the GSB, it serves as the drainage layer as in the case of the rigid pavements. Now to prevent the failures due to the excessive moisture contained in the subgrade soil, the crushed stone aggregates, they are preferred in the granular subbase course, which actually contains the high permeability. The coarse graded aggregates with the low percentage of the fine material, which is less than 5% finer than 0.075 mm size, they will serve to be a major ingredient to provide the good drainage layer. Next, the drainage layer. So an effective drainage layer under the cement concrete pavement, it will be beneficial for the following factors. First, it will increase in the service life and improve performance of the cement concrete pavements. The prevention of the early failure of the rigid pavement due to the pumping and the blowing action of the water. Then the protection of the subgrade against the frost action in the frost susceptible areas, majorly in the cold countries. Next is the base course. Now the granular base course is generally provided under the cement concrete pavement slabs, and the base course provided in the low volume roads and in the roads with the moderate traffics. The roads, they are carrying heavy to very heavy traffic loads, high quality base course materials they are required, and the lean cement concrete or the dry lean concrete is being used. The dry lean concrete layer, it provides a uniform support. It is a high K value and an excellent working platform for laying the PQC. Next, the PQC pavement slab. So for the pavement quality concrete, we'll have to make the use of the M40 cement concrete mix with the minimum flexural strength of 45 kg per centimeter square. The cement concrete pavement slab, it should withstand the flexural stresses which will be caused due to the heavy traffic and the wrapping effects due to the temperature. The high quality cement concrete mix with the high flexural strength, it will be used in order to construct the pavement quality concrete slabs. So using the steel reinforcement, when it is not to bear the flexural or tensile stresses developed, we can go with the PQC slabs. Now, Again, we can see the various layers in the rigid pavement. Starting from the top, we have the pavement quality concrete. That is a concrete which will have the properties required for the construction of a pavement. Next is the dry lean concrete, then the granular subbase, then the subgravel, then the embankment, and then followed by the overall ground level, and lastly the cleaning and the graveling which has been done onto the natural strata. So the rigid pavement, it consists of the subgrade, subbase, base course, separation layer, the pavement quality concrete pavement, and the joints in the cement concrete pavements. So these are all the basic components of a rigid pavement. The separation layer, which consisting of a suitable base course before laying of the pavement quality concrete slab, in order to prevent the bonding between the two, it has to be provided. So again, we can see the basic components of the cement concrete pavement. So we have the entire slab with the surface smoothness, then the longitudinal joint going throughout the length or the length of the pavement, then the transverse joint which actually go perpendicular to the length of the road, then the tie bars in order to bind the two slabs together, then the subgrade, the base course, the dowel bars, etc. So these are all the basic components of the concrete pavement. So with this we shall stop. Thank you.